Hello again. Welcome to another lesson in Algebra 1. Today we are covering section 2.6 and 2.7. 2.6 is the division of real numbers and 2.7 is square roots and comparing real numbers. Alright, so which property is demonstrated below? This is our warm-up problems. If you haven't tried these properties, please do so first. It really will help you learn them better. Okay, so number one again, negative 1 times 3x times 5 equals negative 3x times 5. In this case, we are timesing 3x by negative 1, and then it changed 3x to its opposite. So this is the property of negative 1. Number 2, 0 parentheses 4 plus x turns into 0. We're multiplying something by 0, and it turns into 0. So this is the property of 0. Okay. Number 3, 12x plus 8 equals parentheses 3x plus 2, close parentheses, times 4. So our parentheses went away because we distribute the 4 into the inside. So this is our distributive property. Number 4, 2 plus 3x plus 3 plus 4x. And then on the other side, 2 plus 3 plus 4x. And the only thing that's moving is the parentheses. These are all the same and in the same order. So this is going to be associative. Okay. Number 5, 2, and then parentheses 3x plus 0, and then 2 parentheses 3x. So we added 0 to 3x, and it didn't change its identity. So this is the identity property. Okay. Remember, the additive identity is 0, and the multiplicative identity is 1. So we can always times something by 1 or add 0 to something that doesn't change. Okay. In this one, I'm adding negative 12x plus 12x, which are opposites of each other. So our multiplicative inverses are additive inverses of each other. So this is our inverse property. Okay. Number 7, inside the parentheses we have 3xy times 1, and then the 1 disappears. That's because timesing by 1 does not change the identity of the 3xy. So this is our identity property. And the last one more time, we are distributing. The negative 3 hops the fence. So this is the distributive property. It makes the parentheses disappear. Okay. Down below, this is some practice for what you're doing in Khan Academy right now. So combining like terms and then combining like terms with distribution. So 4x plus 5x is 9x. You'd add 4 plus 5, and then which is 9, and then put the x back because 4x and 5x are like terms. So in number 10, we're really adding 1 plus 4 because there's a 1 in front of the x even though we don't write it, which is 5, and then putting the x back. In number 11, the like terms I'll circle in red. That's these two. So this is 3 minus 6, which is negative 3, and put the t back. And then the 8 doesn't have any buddies, so we put him over here. Okay. Number 12. We have 5 parentheses 2x minus 8 plus 30. So first I have to distribute the 5. So I'll have him hop the fence, and he'll become 10x and minus 40. And then we bring it along to plus 30. Okay, and then here, we look for like terms. 10x doesn't have any buddies, so he comes right down as 10x. And then negative 40 and positive 30 are constant terms, and they can add together to make negative 10. And this subtraction takes the place of the negative there. So it's 10x and negative 10 right next to together. And a subtraction and negative are really the same way. Just sometimes we need it if we have something in front. For instance, if we had 10x minus 10, I scratched out the 10x because I didn't want it. See, that minus suddenly becomes a negative. Number 13, 7w minus 7. We're going to distribute the 7. So 7 times w makes 7w. And then 7 times 7 will make 49 here. It's positive 7 times negative 7, so it stays negative. Then we combine the like terms of the w's, and we get 12w, and then we bring down the 49. Okay. Number 14, I have negative 2 times 4, which is negative 8, and negative 2 times negative 2, which is positive 4. And then I have to distribute this negative. This can be a little tricky sometimes. So a negative times a 3 makes negative 3x. And a negative times a positive 1 makes negative 1. The negatives are covered by those subtractions, okay? So our like terms are positive 4x and negative 3x, which make 1x. I don't need to put anything there. And then negative 8 and minus 1 make negative 9. So our real answer is x minus 9. But if you put 1x minus 9, fine with me. Okay. All right, the reciprocal of a non-zero number a is written as 1 over a and is also the multiplicative and is also the multiplicative inverse of a. So reciprocal and multiplicative inverse are the same. And is also the. You don't need that the there. Okay, so the product of a non-zero number and its multiplicative inverse is always 1. Why doesn't 0 have a reciprocal? So let's answer this question real fast. So if I try to do 0 and then its multiplicative inverse or reciprocal would be 1 over 0. Okay, so that means I should be able to divide 0 into 1. So what number could I put up here that would be big enough to times by 0 and turn it into a 1? And the answer is none. So like say maybe try 100. 100 times 0 would be 0. We subtract it, we still got 1. So we can never get rid of the 1 there. That always have the same remainder as what we started with. Okay, that's why we're not allowed to divide by 0. Okay, so the inverse property of multiplication. The product of a non-zero number and its multiplicative inverse is always 1. In algebra, that's said like this. A is the non-zero number. 1 over a is its reciprocal or multiplicative inverse. If I times them together, I get 1. Here's an example in real life. So 6, its multiplicative inverse was 1 over 6, because I flipped over 6 over 1. I times them together, I get 6 on top, 6 on the bottom, and that reduces to a 1. It works for all fractions. So 2/3, if I times it by its reciprocal or multiplicative inverse, remember they're the same thing, I get 1. 6 divided by 6 is 1 still. So what is the multiplicative inverse of negative 9, or negative 9 over 1? And the answer is negative 1/9. I still need the negative there, though. Don't get rid of them. What is the multiplicative inverse of 3/4? It's 4/3. Remember, a number and its multiplicative inverse are not equal to each other, so when you're doing the classwork next time, please don't set them equal. Okay? All right, division rule. This is why we learn the multiplicative inverse. If you want to divide two things, you really make it a multiplying problem. Just like if we want to subtract two things, we make it an adding problem. Same thing. So in order to do that, we change the divide to a multiply, and we multiply it by the multiplicative inverse of the second number. So in algebra, it looks like this. A divided by B is really A times 1 over B. Okay. An example in real life, numbers, 6 divided by 3 is really 6 times the reciprocal of 3, which is 1/3. If I multiply these together, I get 6 over 3, which is 2. Okay, we already knew the answer was 2. We're just showing it with that. Now, I don't use multiplicative inverses unless I have fractions or things that I need them for. For instance, I know negative 64 divided by 8 is positive 8. I'm not going to do all that rigmarole up above. I'll just put 8. Okay? But when I get to something like 5, this is where I need it. 2/3, and then I'm going to change the divide to times, and I'm going to change the 4/5 to 5/4. So that's 2 times 5 for 10. 3 times 4 for 12, and then I could reduce it to 5/6. Now remember, you can do cross-canceling here, so you don't have to reduce at the end. So this could become a 1, and this could become a 2. 2/4 reduces this to 1/2, so I can reduce in the problem with any numerator and any other denominator. And then 1 times 5 is 5, and 3 times 2 is 6. So you can just multiply and then reduce, or you can reduce and then multiply out the final answer. Okay? All right, so number 6, this is negative 20. I'll go ahead and put it over 1 times, changing divide to times. And then I got to change negative 1/2 to its reciprocal, or its multiplicative inverse. Remember, same word. And then I multiply them together. Okay, there's only ones on the bottom, so this actually just turns into 40. Okay? Negative 3/4 times, changing divide to times, and then it was 15 over 1, so I'll make it 1 over 15. So multiply the tops, multiply the bottoms, and reduce. But remember, you could have done this. This would turn into negative 1, dividing it by 3. This will turn into 5. So negative 1 times 1 is negative 1. and 4 times 5 would give me 20. So either way, I get negative 1/20th. Okay? All right, flip it over. Andy recorded the low temperature each night at his home during January. Over 5 consecutive nights, he recorded the following temperatures: -2, -10, 6, 1, -1, and 2. What is the mean low temperature at his home on these nights? So remember, the mean is the average. To find the average of some numbers, we add them all up. And please write down the work for this, even on a test or quiz, because I need to see that what you're doing. Don't just write a final answer. And then we're dividing this by 5, because there are 5 numbers. All right, so if we add up these, we get, let's see, that's -13 plus 8, which is -5 over 5, which is -1. So the average temperature was -1 degree Celsius. There's my final answer. Okay. All right. Number 9, we're trying to simplify these expressions. If you look in the book, I'll show you what it will look like, and then I'll show you why I don't do it that way. There's a much easier way, I think. So this is 2x minus 8 divided by -4. And then they say, okay, well, can't do that. Got to make it a multiplication problem. So then they times by -1/4. And then they do the distributive property. So they distribute the -1/4 in there, which makes -1/2 x. And they distribute the -4 in there, and that makes +2. Okay? This is a lot of work, I think. It's a much quicker way to think about it. If you just say, hey, look, this is really the distributive property for division. So I do this. I say, okay, I need to say the negative or positive 2x divided by -4. 2 divided by -4 makes -1/2, and you put the x back. And then -8 divided by -4 makes +2. And then when you're done, it makes a little heart because we all love math so much. Okay, that's my joke for the day. So in this one, I have -6y divided by 3. I'm distributing with the division instead of multiplying. So this is going to give me -2y. 6 divided by 3 is 2, and put the negative back. And then over here, we have 18 divided by 3, which makes +6. Write the positive sign, and then magically it turns into a plus. Okay. All right, on this one, -10z divided by -5 makes 2z. And -20 divided by -5 makes +4. So 2z plus 4. And then in our last one, 40 divided by 8 is 5x. 32 divided by 8 is 4. I find this much easier than the book's way, but you are, of course, welcome to use the book's method. Okay? All right, square roots of a number. If b squared equals a, then b is the square root of a. So 3 squared equals 9. Therefore, 3 is the square root of 9. And -3 squared equals 9. Therefore, -3 is also the square root of 9. Okay? All positive real numbers have 2 square roots. A positive square root called the principal one. And this should be LE, sorry. And a negative square root. The calculator on only show the principal square roots. Okay? A square root is written with the radical symbol, square root symbol, this guy right here. Okay, the number of the expression inside the radical symbol is called the radicand. So this is my radical symbol. My radicand in this case is 25. And this guy has 2 answers. It's +5, and it's also -5. Now, when we write our answers, unless I'm asking you otherwise, we're really just going to use the principal square root, the one the calculator tells you. Okay, so recall, the square root of a number is not a perfect square. It is a rational number because it cannot be written in the form of a over b. So this guy turns into a +5 because perfect square here. But if I said, what is the square root of 27? This resulting number, 5 point something, that something will never repeat. And it will also never terminate. And that's because it's an irrational number, just like pi. So cannot repeat and doesn't terminate. Goes on forever and never does the same. All right, so for exercises 13 through 16, sorry. evaluate each expression. So 13 is going to become 3. Remember, we're only going to do the principal square root. 3 times 3 is 9. Negative square root of 25 will become negative 5. Square root of 25 is 5. Here we're going to do plus or minus, and then 64 is a perfect square, so we'll get 8. And here we're going to do negative, and 81 is a perfect square because 9 times 9 makes 81. So it's really useful to memorize the perfect squares. The perfect squares, the first 5 of them are 1, because 1 times 1 is a perfect square. 4, that's 2 times 2. 9, that's 3 times 3. 16, that's 4 times 4. And 25, that's 5 times 5. Okay? We can use those perfect squares to help us approximate each square root to the nearest integer. And sorry, this should say 18 through 21 here. Okay? And here's how we do it. We say, what two perfect squares does 32 fall between? Well, it falls between 6 times 6, and it falls between 5 times 5. So which one would it round to? Okay, well, we don't need a calculator to figure that out. We just say, hey, which one's it closer to? It's only 4 away this way, and it's 7 away this way, so it's going to be closer to the square root of 36. So this would be about 6, because the square root of 36 is 6. Okay, so 50 falls between 7 times 7, which is 49, and 8 times 8, which is 64. You can tell really fast it's much closer to 49 than it is to 64. So this is going to be about 7. Okay. 14 falls between 4 times 4, perfect square, which is 16, and 3 times 3, which is 9. It's much closer to the 16. So this will be about negative and then 4. All right, so this last one here, you probably don't have these perfect squares memorized up to 350. I don't expect you to. So I would pull a calculator out, and then you can type the square root of 350. And that's going to be 18.7 something. So this will round to about 18, but we had a negative in front, so negative 18. Okay. Last one. A square garden has an area of 225 square feet. How much fencing should you buy to go around the garden? All right. So here's our square garden. It has an area of 225. That means there are 225 little squares inside of here. Now, it's supposed to be the same length on all sides. That's what makes it a square. Okay, and it has 90 degrees in the corners. So the area formula for a square is a number times itself makes 225. That means x squared is 225. So what is the square root? That's how we would solve this. Okay, so we would do square root to both sides. And this is going to be 15. It's one of our perfect squares. Now really it's 15 or negative 15, but we only worry about the principal square root right now. Okay, so how much fence do you need to buy to go around the garden? Well, it's not 15. That's each side. There are 4 sides. So when I add them all up, we're going to need 60 feet of fence. Okay, I'll see you next time. We'll practice this. And then your homework will be your test review. And you'll have a test to class afterwards. Okay, see you in class.